Oh, hi guys and girls, Emma again. Welcome back to the spare room. It's some time since I've done a review on a new tool. Probably should do it more often, but at this point, I don't buy a lot of tools that haven't already been reviewed, and I don't do the Banggood thing. I've always got nice things coming in, but I thought I'd do an absolute review on this. I've been looking for one for a little while. Been using a friend's off and on at his workshop, and it comes in a fairly nice box with packaging, etc., and a bit of stuff in it. This is the Machinists Calc Pro, which is the second generation one. The first one doesn't quite have as many features. What I thought I'd do is we'd have a look in the box. Pretty decent box, no tape or anything on it. It's just a proper cardboard box, and it's got a QR code we can scan for more information, and do a bit of a look at it and a bit of a review of it, and then do half a dozen or 10 basic functions and see if we're liking it or not. It's got a book. Made in America, Carson City, Nevada, USA. Design in the United States of America. This is printed in China. I'm not sure where this is made actually, to be honest. But it's an American machine. This is the book, which is basically shows all its functions. Let's pull it out. Wrapped up in a plastic bag. This has got an armadillo case, a rubber case on it. Looks like it just pops out. We'll do that first. Looks like it's got a battery in it. Takes one CR2025, which is pretty sensible. It's not silver oxide or something stupid or alkaline now. Their lithium batteries are CR2025, which means it's 20mm diameter and 2.5mm thick. 3-volt lithium battery, so that should get pretty good life out of that. Instructions how to fit it. It has got a space on the back for pocket reference guide, it says. I'm not sure if that's actually with the calculator, but this is a rubber case. ABE would tell us all about where it was made and what it was made out of, etc, 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 and so would others. And push that in and hook it over the bottom. We've got a cover to keep the dust and oil out, which is really good. It's got a quick reference guide on here. Materials and processes and tools. Some of the basic functions. It's got an on-off button, it's got a metric and inch button, and it's got numbers, surface feet per minute, RPM, drill sizes, thread sizes, and then basic trigonometry buttons, diameter, material, process tool, and a lot of other functions as well, I think. So that was right out of the box. We're a month further down the track, and I've used this a lot, a whole lot. It's got a cover on here. I don't think it's actually been used. I'm not sure that's a particularly useful thing, because mostly it just kicks around in the dirt, which is probably, I should use the cover. Let's set this up on a sanding sponge so that I can actually see it. It doesn't move around too much. So if we want to convert, say, 7/16 of an inch, 7 and then this dash, then 16th, it will give us the fraction. It's inches, that'll give us our decimal, is 4.375, which we knew already. If we press the convert button and then millimetres, it gives 11.1125 millimetres. That's pretty useful. That's a function that I use all the time. Works the same other way. If you've got 42 millimetres, it says millimetres, convert to inch, 1.6535433 inches. whatever. So that's pretty useful, and it sits around and it does that all day, every day, backwards and forwards. It's good, it's accurate, it's excellent. If we've got 1/8 of an inch and we just want to convert it to decimal places, just press that button. Fix. We can press the inch button too, will do exactly the same thing. Say we 64ths, and we want to find the nearest metric size. We can convert that to metric as 10.715. Now we've got 10.7 mil drill, and that's going to be a bit tight, we think. So if we press the drill size button, 27/64 drill is 422 of an inch. If we press it again, that's 10.75 mil drill. If we press it again, it'll give us our next size, which is 10.8 millimeters, or 4.25. If we still think that's a fraction tight, we can press it again, and it'll give us 11 millimeters as the next size up. 7/16 is the one after that. 11/20, and so on. 29/64, etc., etc., etc. That also has number drill. If the drawing calls out a number 65 drill, and we press drill size, number 65 drill size is 35 thousandths of an inch. We want to find a metric equivalent, we can do that. So the next size up, or the closest metric one, is 0.9 of a millimeter, which is the same decimal equivalent. So that's a pretty useful function too. You see a lot of old drawings with number sizes on them, or fractional sizes, and all you've got to set a metric drill bits in 0.1 increments. That's pretty helpful, like really helpful. It does some cool things with threads. So we've got a 1/2 inch thread, so we go in 1/2 inch, press the thread size, and it leaves a dash here, and it gives us our thread tolerance. It's 2B, which is the standard thread tolerance. We can change that. Or we say we want 13 threads, which is odd bod. As UNC, it's not that odd if you live in America. Press the thread size button again, and it gives us our thread pitch is 0.077, which is 77 thousandths of an inch between threads. It gives us our tap drill size, which is 27/64. Press it again, it gives us a roll tap drill is 11.8 millimeters if you want to use a roll tap. Close fit drill is 33/64 if you want a good close fit hole. And a free fit drill is 1732. That's to that thread tolerance. If you change your thread tolerance, if your drawing calls out a thread tolerance, or you think it needs to be a little bit more precise or whatever, you can change that and it'll give you the equivalents. It'll give you pitch diameter, which is 0.450, minimum and maximum, and the minor diameter, the major diameter, etc., etc., etc. So that's pretty useful. If you want to push that thread envelope and work out your dimension over 3 wires, this calculator will sort that out. So usually I've got to sit down and look in books and look on charts, and the chart in my thread wires is too small to really read without a magnifying glass, etc., etc., etc. This is pretty useful for that. So we've got a thread, say, let's do the same one again. 1/2 inch, thread size, 13, thread size, and then the wire size button. Ideal wire size is 0.44 threads per inch. And we can use, if we press this again, we can use maximum wire size in that thread we can comfortably get away with 69 thou or 43 thou. So that's a pretty useful function if you're measuring with wires on threads. It's something that I've used once. It's probably something I'm going to use again. It's good to know it's there, and having the habit to get this out and to use it rather than to mess around and find the right chart. It's a really useful thing. You can go back the other way too, and that'll give you your minimum and maximum 3-wire measurements, which is a pretty useful thing. Some of the advanced functions here it'll do a bolt pattern. So if you haven't got that function in your DRO, or if you want to set out a set of bolts using your hand wheels, and you've got, say, 6 holes in a pattern, and you've got your milling machine set up on the first hole, and you've got 1, 2, 3, 4, 5 other holes to drill from that point, then you can use this, and that'll give you your offset this way and your offset this way, and then your offset that way, and your offset that way, etc, 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 and that'll give you your coordinates to mark those holes out. So that's a pretty useful function. I'm not sure if I'm ever going to use that, but I've messed around with it and it seems to work. So it'll give it to you from 0 position, or it'll give it to you from the center position. So if all you've got is the center, it'll give you 6 points or 5 points or 3 points or 27 points, whatever. It'll give you it'll work that out for you. So that's a function that it does. A little bit complicated, but it does it. Now, it'll also give us feeds and speeds for tool cutting. I don't have a machine with power feed on it, so I haven't used that function yet. I know it does do it, and it gives you a feed rate based on the cutting feed and RPM, and a feed rate for drilling and turning, and it will give you a feed rate for a milling machine based on your feed per tooth RPM and your number of teeth on your cutter, and it'll give you a feed rate for end milling. It'll give you a cutting speed for various tools, and it'll give you chip load, which is fairly useful, and it'll do all that in different materials. So you can scroll through, I've messed with this a little bit, you can scroll through the different material button. This one, 1020, 1045, 1060, 4140, 4340, 52100, 304 stainless steel, 316, 410 stainless steel, 430, P20 tool steel, H13 tool steel, T3 aluminium, T6 aluminium, T5 aluminium, titanium alloy, another titanium alloy, 718 alloy, alloy X, Haynes alloys. A lot of these I don't even know what they are, but you can select that material and it'll give you a different cutting speed depending on which material and what your cutter is. So that's pretty useful, and there's a lot of potential for this in this workshop. I think with most electronic toys, you only use the things you're comfortable with. I've been trying to push myself to use more and more of these functions. It'll convert tons and grams and kilograms and miles and feet, centimeters, things like that. If you're an American working with metric, it's probably a really good thing. If you're an Australian or English person working with feet and inches in this day and age, when it hasn't really been a recognised system in my lifetime in Australia, that's a good thing too, because a lot of model engineering drawings and a lot of even workshop books and drawings are more than 40 years old, so it's a pretty useful thing. It also does trigonometry fairly easily, the same as any calculator. Circumference and area is very, very simple. Say we've got a 100mm circle, and that's our diameter. Press the diameter again, it gives you a circular area, and the circumference of the circle, which is 3.14159, which is what we expected, and back to diameter. It'll do the same in imperial. So if you've got a 4-inch circle and you want to know exactly the same thing, if you press this, circular area, circumference in inches. So that's a pretty useful function. There's a lot of trig functions in this that you use when you need to, and if you're proficient with trig, then you'll know exactly which buttons to press. It's very, very self-explanatory, and that's very helpful the way it's laid out. Once you've mastered one function with it, working out the other functions is very, very simple, because you know exactly, this is the shift button, and you know there's two sets of instructions on here, or 2 sets of labels. Like adjacent, opposite, hypotenuse, and angles are also your sine, cosine and tangent, and the percentage of thread. We can change the thread class by pressing the, if we've got the same thing, if we've got our 1/2 inch thread size 13, you can change it to US International Thread or a few others too. Now this is set up in imperial, and you can convert it to metric, I believe. I haven't had any luck at all with that. Maybe someone knows how to do that. At this point it seems to revert back if I do it, and the easiest way is just to press the metric button. It's as simple as that. You can set it up so it defaults to metric, I believe, according to the book, but the instructions are sketchy in that particular regard. So I haven't managed to do that yet, and that to me is probably the one downside of this. However, it's not really a problem, because if you select one of these buttons every time you enter something, 100 inches, 100 millimeters, then it automatically knows which system you're working in. And if we've got thread size 100, say 10, which isn't actually a thread, and that'll give us our standards for then. So metric thread standards are all there too. So there's really, it's ambidextrous like that. It works in metric and imperial just as easy, but until you press that button, it doesn't know what it is. So that's what I think about this. I really like it. It's had a fair bit of use, as you can see. It's getting a bit grotty, but it's on my bench all the time, and I reach for it now rather than a chart, which is excellent. And it's just one thing to lose, basically, compared to several charts. I've got charts here everywhere. And while some of them are cool and some of them make great decorations, messing around with a magnifying glass looking up something on them is a bit of a pain when you can just reach this out 3/16 of an inch, which is our keyway we cut yesterday, inch, 187th thou, divide by 2, 93.75. Convert that to millimeters for how far you move it across. Job's done. Very, very simple thing. So anyway, I wanted to share that with you. It's not a cheap calculator. It was the other side of $100, but I have used it a lot more than I thought I would, to be honest. And right now I really wouldn't be without it. So I hope this is useful to someone. someone who's looking at buying one, if you do the same 3 operations all the time, you know them off by heart, and it's unlikely in your job or your hobby that you'll push yourself any further, don't bother. Look it up on a chart, do it the old-fashioned way. But if you're messing with threads, if you're reading drawings, if you're using 2 or 3 different standards, and if you're using 2 or 3 different machines with different standards on them, seriously, go get one, because it's a pretty useful thing. If you don't want to pay full price, they do turn up on eBay. I've seen 3 or 4 since I bought this on eBay. Unwanted gifts, things like that, that have gone for a pretty good price. So put it in your search list. Thanks for watching. Be kind to each other, and more soon, guys and girls. That's my review of the Machinist Pro Calculator 2.